In today's ever-changing and fast-paced, technology-driven world, drone racing is quickly emerging as an exciting new sporting event. One of the main problems existing, however, is that fixed camera stations and drone-mounted cameras are currently limited in their ability to capture quality racing drone footage. The fixed camera platforms tend to miss a large portion of the action which draws viewers to the sport, such as the passing, maneuvering, and crashing of drones. Drone-mounted cameras can capture some of this action, but they are limited to unsteady, low-resolution footage that is in first-person view only. In order to possibly solve this problem, our design team developed and created 2 units that are capable of tracking a drone through 3-dimensional space. Each of these units can be mounted to a standard camera tripod and can accommodate up to a 4.5-inch wide camera of your choosing. We began the design process by rendering the multiple components of each enclosure using CAD software. Each piece was then printed on a MakerBot Replicator 5th generation 3D printer. Each enclosure contains an Arduino Uno, a Raspberry Pi 3, a power distribution board, a 5-volt UBEC, a DecaWave EVK1000 ultra-wideband card, a powered USB hub, a battery, a 180-degree servo, a 330-degree servo, and a few bearings to make the enclosure operate smoothly. For our configuration, we will have 3 UWB cards set as anchors and 1 UWB card set as a tag. Anchor 0 will be attached to a laptop, and the other anchors will be installed in the enclosures. The tag will be attached to a drone as it flies along the course. Anchor 0 will output the raw data location to the laptop. Software on the laptop will then process and transmit the data via a UDP connection over Wi-Fi. Inside each enclosure, a Raspberry Pi will receive data over Wi-Fi. That data will then be processed and converted to angles relative to the anchor location of that unit. These angles are then sent serially to an Arduino Uno, which will then control the servos using pulse width modulation. All of these components will be powered by a battery. The voltage will be controlled via a 5-volt UBEC, which will then be sent into a power distribution board to power all of the units. Our team's combined skills and knowledge have been invaluable in the completion of our project. Various courses taken by each of us at UAH have aided in our ability to carry out and complete this joint endeavor. For example, embedded systems taught us how to interface with and program microcontrollers, and software design and engineering taught us how to use crucial QT development tools. Computer networks was also extremely useful because it taught us how to use UDP sockets. Future job and life skills were also acquired by us as we worked as a team. Proper time management, learning to rely on other team members, and public presentation techniques were some things we learned, just to name a few.